Hello everyone. Welcome back to Data Lingo Solutions Deep Dive series. This is the second part of the two-part presentation on the magical context topic. If you are wondering, what does Dory, the adorable and forgetful blue tank fish, have got to do with AI, or have not watched the part 1 of this presentation, please watch that here. At Data Lingo Solutions Deep Dive series, we demystify complex AI concepts, transforming them into clear, understandable content for enthusiasts and experts alike. In this second part of the magical context presentation, I will explain how the implementation of context not only solved yesteryear's problem of bringing conversation ability to LLMs, but is also shaping both RAG and agents. As you may remember from part 1 of this presentation, here is a prompt response flow diagram showing how the interaction works. You submit a prompt using either a screen interface or a voice assistant. The vendor cloud receives the prompt and attaches the context, which consists of previous prompts and responses arranged in reverse chronological order. This entire stack is then sent to the LLM for processing. This context allows the LLM to understand the history of the conversation and respond more appropriately. The LLM processes the prompt by giving the current prompt the highest priority, followed by the context, and only accessing its own knowledge base if it needs more information to generate a response. This flow is how the system manipulates the LLM's attention to ensure accurate, context aware responses. Now, let's understand how information flows inside the vendor's cloud. Inside the cloud, there is a module that receives the prompt. There is also a file that stores all the previous prompts and responses for that user in the current conversation thread. The technical term for this file is LTC, which stands for long-term context. Long-term here means durable or persistent. Essentially, no matter how much time has passed, when you return to the conversation, the context will still be available and ready to use. The data stored in the LTC includes more than just prompts and responses, but for simplicity, we focus on those elements for now. The receiver module appends the LTC to the incoming prompt and sends it to the responder module. The responder module then sends the entire stack to the LLM, retrieves the response, formats it, and sends it back to the user. This setup works well for use cases where the LLM has all the information it needs to respond, either from the prompt itself or from the context provided or from its knowledge base gained during training. However, for situations where the prompt and the context don't provide enough information, the responses generated may be poor or even hallucinated. For example, in customer support requests, the prompt and context might not contain enough details about the specific product the customer is asking about, leading to incomplete or inaccurate answers. In such cases, the information in the context needs to be augmented to provide more relevant data. Before diving into technical details of how that augmentation is done, let's start with an everyday example. Consider this financial advisor. She is an expert in finance and knows her field well. But to provide the best advice to her clients, she needs to update information. Let's say her client is asking where to invest their funds. The advisor already has her client's detail and financial goals written in her notepad, which gives her context for the meeting. However, to make the most informed recommendation, she does not rely solely on her own knowledge. She reviews the latest fund prospectus and market reports to ensure she has the most current information. By combining her expertise with these external real time sources, she can offer better, more relevant advice to her clients. Now, think of this process when we talk about retrieval augment generation, aka RAG. Just like the advisor pulls in the updated information before meeting her client, RAG enables LLMs to retrieve real time, relevant data from external sources, enhancing their responses and making them more accurate and up to date. Let's take a closer look at how RAG works. Here is the flow for augmenting the context. The key component is the vector DB, which contains additional knowledge and has the ability to retrieve relevant knowledge on demand. Its knowledge base is curated from the external or private data sources and can be periodically updated to keep the data fresh. The receiver module not only appends the context to the prompt, but also sends the prompt to the vector DB. The vector DB comprehends the prompt, retrieves relevant information from its knowledge base, and attaches it to the context. When the LLM receives the request consisting of the prompt, the context, and the additional information from the knowledge base, it has everything it needs to respond well. The basic problem that is being solved here is training an LLM is very expensive. Once trained, the knowledge is frozen. The technical term for this is the cutoff date. Any knowledge that was not available by that time, whether it happened after the cutoff date or is private data that was not available during the training, can be augmented by the knowledge retrieved from the vector DB, which can have the latest or private information. Did you notice how context plays a crucial role here? It leverages the LLM's behavior of giving higher attention to the latest prompt and the information in the context. This is a very high level introduction to the RAG system. In my future videos, I will provide more detailed information about RAG. Let's look at some applications of RAG technology. In customer support, RAG enhance responses by pulling in specific product details, policies, or updates that may not be included in the LLMs during its training. This ensures the customer gets the most accurate and relevant answers, improving overall service quality. In product discovery applications, RAG can help users explore products by retrieving the latest information, reviews, or specifications. This is particularly useful for e commerce platforms where having up to date data can guide users to make informed purchasing decisions. And in semantic search products such as Search GPT, Perplexity AI, or even Google Search, RAG ensures that the LLM is supplemented with the most current and relevant data, refreshing information continuously. This allows users to retrieve not just the most popular results, but the most accurate and contextually relevant ones. RAG technology is the backbone of many recommendation engines, be it movie recommender or stock recommender or fashion recommender, where complete information about the user and available products is needed and is retrieved from the vector DB and used to generate personalized recommendations. I encourage you to explore RAG use cases in your own industry. Think about how RAG technology could apply to the work you do or the problems you are trying to solve. If you find this information useful, please like and share it with others who might benefit. Please consider subscribing to the channel and hitting the bell icon below to get notified whenever we release a new video. Now, let's move on to another exciting emerging technology as of mid 2024: AI agents. These agents have the potential to automate many tasks that humans perform today, hence the term AI workers, offering new opportunities for innovation and efficiency. Before jumping into AI agents, let's understand how machines are assembled. Take this engineer, for example, who is assembling a toy car from various parts. What does he do? He refers to the instruction manual, inspects the parts, understands the final product to be built, and then plans how to put everything together before assembling it. Now, this is very similar to how AI agents are built, just with different terminology. In the case of AI agents, the parts the engineer works with are called agents, or at a more granular level, tools. The instruction manual he follows is called the tool spec, which outlines how the agents should work and interact. And the fully assembled toy car becomes an agentic system, a complete AI system capable of handling complex tasks autonomously. Let's look at the flow of information in case of agents. As shown in the diagram, the user starts by sending a prompt. Along with this, previous prompts and responses in the LT context are also attached. Additionally, tool spec, a document that defines agents, their capabilities, and the data they need to perform their functions, is also attached. Based on this combined input of the prompt, context, and agent definitions, the LLM reasons through the required steps and generates a plan. This plan is passed to the executor module, which is responsible for executing it by directing the agents to take specific actions. This framework, where the LLM handles reasoning and the agents carry out the actions, is known as REACT framework, reasoning plus acting framework. This approach is profound because it allows the LLM to go beyond its static knowledge and dynamically reason about how to achieve a goal with the tools it has. I will cover the REACT framework in more detail in a future session, but for now, take note of how we augment the LLM's knowledge by adding tool spec information to the context. This helps directing the LLM's attention to specific data it needs to prioritize over its pre-trained knowledge. Let's take an example. Let's say the user sends a prompt. Hey, Can you please analyze the Fed's monetary policy report and email it to me? This prompt, along with the tool spec, is received by the LLM with the context. The LLM parses the prompt and identifies three key actions: search, analyze, and email. Based on this, it generates a plan to carry out these actions in sequence: search, analyze, email. The executor module then follows this plan and delegates each step to the appropriate agents. The search agent handles searching for the report and downloading it. The analyze agent processes the report and extracts insights. Finally, the email agent sends the analyzed report to the user. How cool is that? The real strength of agents is fully realized when the agentic system functions as an AI worker connected to a continuous data source, like an IoT system. In this setup, data flows into the system automatically, enabling the AI worker or agents to process information in real time and take actions continuously. In the diagram, you can see how the data source provides ongoing data. The receiver captures this incoming data and sends it to the LLM. The LLM reasons through this information using the tool spec and data provided and generates a plan. The plan is passed to the executor, which then activates the appropriate agents or AI workers to handle tasks based on the plan. These AI workers continuously process and act on new information as it comes in, reducing the need for human supervision. This dynamic, always on capability is what makes the agentic system so powerful. It can handle real time data and make decisions, allowing humans to focus on higher level tasks. Here are just a few examples of how agents technology is applied in different industries. A patient care agent can monitor patient vitals and other data continuously from medical instruments, taking predefined actions if something goes out of range, or alerting healthcare professionals if needed. A power grid agent can track and analyze load fluctuations in real time, ensuring optimal power distribution and addressing potential issues before they cause outages. A CCTV monitoring agent can continuously analyze video footage detecting anomalies or suspicious behavior and alerting human operators as needed. These are just a few of the many applications for agents in real world scenarios. Can you think of how agents can help automating the tasks in your industry? In a separate session, I will go deeper into these use cases and explain how agentic systems are transforming industries. To conclude, context is the driving force, making stateless LLMs conversational. Without the construct of context, LLMs would have been like Dory from Finding Nemo, forgetting previous interactions. In retrieval augmented generation, context helps in incorporating relevant real time information, enhancing accuracy of LLM's responses. It shifts the LLM's focus to fresh data, allowing for better informed results. In agentic systems, context not only guides LLMs but also coordinates agents. It ensures that real time data, long term memory, and tool specifications work together seamlessly, enabling intelligent decision making and actions. In short, context elevates LLMs from static models to dynamic systems capable of conversations, retrieving data, and executing tasks in real time. Before you go, I encourage you to explore AI use cases in your own industry. Think about how these concepts could apply to the work you do or the problems you are trying to solve. If you found this session helpful, please subscribe to our channel and hit the bell icon to stay updated with our latest videos. Feel free to leave any questions or comments below. We would love to hear from you. Thank you again for watching, and I will see you in the next session.